Hi, everybody. Thanks for joining us today. My name is Andy Ellicott, and we're here to learn about stored procedures and an easier way to implement those and manage them. All right, so without further ado, let me turn it over to my colleague Harry, who will talk to you about how DBOS simplifies the implementation of and use of stored procedures. Harry?
Thanks, Andy. I like to start my presentations with a personal anecdote, some kind of story that relates to the topic at hand, but I'm not going to do that today. I can't do that today because I've been a developer in the IT industry for over 3 decades, but I have never written a stored procedure that's been deployed into production. I've built so many database applications. I was at Microsoft for 21 years, and I spent a third of that working with customers in the enterprise space. And those customers primarily care about database applications. I've read the docs, I've done the labs and tutorials. I'm familiar with half a dozen different object relational mapping systems across a variety of different languages. But I've never built a stored procedure that was used in production, ever. Pretty sure I'm not alone in this. So let's talk about it. Stored procedures are a proven, mature, battle-tested technology. They have a variety of upsides, but in particular, they are fast, both in terms of performance and scalability. And those are two metrics you probably care about a lot if you're an application developer. Faster apps tend to have happier users, and scalable apps require less infrastructure, so they cost less to operate. It's easy to understand why stored procedures are so fast. If you run your business logic, which is to say your data query and manipulation logic, closer to your data, you spend less time traversing the network. The physical database operation, things like inserting rows, scanning table indexes, stuff like that, that takes the same amount of time regardless of where the query originates. However, queries that originate on the app tier each require a separate network round trip. The cost of these network round trips may be small, but it's not zero, and they add up. To show you what I mean, let me show you some sample code. This is some sample code from one of our demo apps. I'm not sure why my printer has decided to start working right now, sorry. This is some SQL from one of our demo apps. You can download this from our GitHub account. This is the create order function from the shop demo application. Now that application uses connects, which is a SQL query builder, allows you to write your queries in TypeScript, and then the library automatically converts them to SQL for you. We support a variety of different object relational mapping libraries in DBOS, including connects. But I want to look at this from the perspective of the database. So I've extracted the generated SQL to include on this code here. The business entity of an order in the shop application is modeled in the database with two tables, as we can see here, orders and order items. This is a fairly common many-to-one bog standard relational database modeling exercise. The order ID column of the orders table is the primary key, and it's an auto increment integer. It's generated on insert and returned by the query, and then later used in the order items insert statement. The thing to realize about this is that this creates a dependency between the two queries. I must execute the first one and get the result back before I can execute the second one. I cannot do these in parallel or anything like that because of this dependency. Now, this is the business logic of the create order function, these two queries. As Andy mentioned, DBOS provides a variety of additional infrastructure for ensuring your code is reliable. And so these two are what the database developer writes. The rest of the queries we're going to see on this are more infrastructure that ensure that this function executes reliably. Now, the first thing we need to do is we need to add code to make this atomic, right? We're going to begin and commit a transaction. Obviously, it would be very bad from a business perspective if one of these insert statements succeeded while the other one failed, right? If you inserted to the order and didn't insert the order items or vice versa. And the way you do this with a database, of course, is with a transaction. Now, making this atomic is important, critical even, but it's not sufficient for making it reliable. This create order function is one small step in a larger business process. or to use DBOS terminology, in a larger workflow. The business cares about ensuring every single step of that workflow is executed once and only once. You'll see this phrase and this acronym sprinkled throughout DBOS presentations and documentation. It's important to the business. We want to create the order once. We want to charge the user's credit card once. We want to ship the order to the customer once. If any of these steps don't happen once and only once, that lends to a bad business outcome that creates a bad business outcome. The problem is computers are very bad at guaranteeing once and only once execution. Computers are fallible. Hardware crashes, operating system segfault, networks go down, security vendors push out unpoorly tested patches. There's an infinite number of things that can go wrong in your application that are outside of your control and will cause your system to crash and need to be restarted. If that happens, all of your interrupted workflows need to be able to be brought back to a state where they were executing at the time of the crash. We need to know which steps have and have not been executed. And how do you do that? Well, you need to basically record the fact that you've done these operations. Not only execute the business logic, but also record durably the fact that you did execute it. And that work has to happen inside of this transaction. If you don't put this work inside of the transaction, you cannot guarantee once and only once execution. Likewise, you also need to check to make sure that the code has not been executed before you execute it. So this two-statement business logic becomes 6 separate queries to run to the database. That's 5 extra round trips if you write this code and run it on your database, on your application tier instead of on your database tier. And as I said, those round trips are not, they're small, but they're not zero, and they add up. Now, what you may not realize about DBOS is that it started as a research collaboration between MIT and Stanford. Several of our founders, including Mike Stonebreaker that Andy mentioned, were part of that research collaboration. One of the projects in that collaboration was called Apiary, a transactional framework function as a service framework, the precursor to DBOS Transact. And as part of that work, they did a bunch of measurements around how much time is spent traversing the network versus executing business logic on the server. And this is what they found. As much as 98% of the runtime of a given function is spent on communication. That implies there is a lot of performance being left on the table if you don't use stored procedures. So if performance is this great benefit for stored procedures, how come nobody uses them? How come they're so rare? How come there are literally scores of object relational mapping systems, but nowhere near as many tools for being able to build stored procedures? Well, the reason is that there's a lot of friction that comes from building stored procedures. For example, stored procedures are typically not written in the same language as your application. Postgres, for example, the default language for stored procedures is PL/PG-SQL. It's a version of SQL that adds imperative programming language constructs like loops and branching. It makes SQL more like a traditional programming language, but you're not writing your whole application in that, right? There's no PL/PG-SQL React or something like that you're going to run in your browser. There's no PL/PG-SQL router code that you're going to run on your web server. So introducing stored procedures, introducing a second language, significantly complicates your application. There are well-known studies that explain that writing your application in a single language reduces effort, reduces cost, reduces maintenance. Stored procedures don't integrate well into your existing developer workflow. They don't deploy the same way. They're not authored the same way. They have very different tools, not just different languages. Getting that stuff to work is possible, but it's harder. They don't version the same way as your application. These workflows are long running, right? The shop workflow starts when the user hits the buy button in the website and it doesn't end until the order leaves the warehouse. That can be hours, days, weeks even. So how do you handle version upgrades in that scenario? Your application tier is stateless, so it's relatively easy to deploy, to tear it down and deploy a new version. It's possible to deploy the old version of the app and the new version of the app on separate servers, and then keep the old app version running until all of the old orders have been processed, and then switch over. You have a lot of flexibility and control in that way. But your database, it's at the center of your application. It's stateful, and so you can't version your stored procedures the same way. Stored procedures are hard to debug. Obviously, databases are not designed to be debugged the same way as application servers are. Visual Studio Code or other tools like it can debug your application code out of the box. But the tools that you need to be able to debug databases and stored procedures, those are more complicated and oftentimes more expensive. These aren't showstoppers, right? These can be addressed. But most application projects, they're limited in the amount of developer time they have, right? You can throw more hardware, you can buy faster hardware, so leaving performance gains on the table unrealized is easier to justify than doing something that's going to require more development effort. The time you spend solving these friction points is time you're not spending on your application. What you need is, say, I don't know, maybe some startup company that's trying to radically simplify database application development, to take on these friction points and make them easy for customers to use. And that's what DBOS stored procedures are. All of the performance without any of those friction points. So let's first talk about the performance. We talked about it in theory, but this is the numbers that you can actually get from our benchmark. You can see the URL down here if you want to clone this repo and see it for yourself. Even with a small number of queries in your transaction function, you see a significant performance upgrade by using stored procedures instead of using app code, business logic running on your app tier. And the more complicated your code gets, the bigger that gap gets, right? Because we're only making one round trip to the database. Plus, so here you have, in the case of the 10 operations, that's 10 business logic operations, plus the additional infrastructure queries that are needed in order to ensure that the transaction is reliable and atomic. As I said, the more complicated the code, the bigger this gap gets. Now, of course, this performance is there regardless of anything that DBOS does. We're just taking advantage of existing infrastructure. What we've focused on is solving those friction points to make it easy to build these types of applications. So first off, they're not written in the same language as your application. Not with DBOS stored procedures, they're written in TypeScript. Now, the truth is we are leveraging a existing third-party extension for Postgres called PLv8. I'd like to give a shout out to Jerry Seibert and the other contributors to that project. This is a trusted language extension that allows you to run JavaScript inside of Postgres. We leverage that extension, and we have built a custom compiler that converts your TypeScript stored procedures to JavaScript, wraps them so that they can execute inside of Postgres. Stored procedures don't integrate into your existing workflow, not with DBOS. They are written in line with your other application logic. The aforementioned DBOS compiler extracts the stored procedure functions from your application. We'll talk about the specifics of how this works in a little bit. But it takes them out of that. So you automatically get your stored procedure functions directly in line with the rest of your code. The compiler also plugs into the migration pipeline. DBOS has a built-in, DBOS Transact and DBOS Cloud have a built-in migrate command for integrating with existing ORM schema management systems. The DBOS compiler integrates into that same logic, so that way you can deploy your stored procedures at the same time that you deploy your schema changes, automatically, without any effort on your part. They're not versioned the same way as your application. Every single DBOS Cloud deployment has a version stamp. And when you deploy your stored procedures to our cloud, we automatically version stamp them. Now, you can, of course, do this yourself. All this code is available. You do not have to use DBOS Cloud. But this allows you to deploy different versions of the same stored procedure and invoke them from different running applications. We actually automatically, we mentioned earlier about this idea that you could keep old versions of your application running. DBOS Cloud does that. We do not decommission a version of the application until all of the business logic that's running against that version has completed. All of the workflows have completed. So you can deploy multiple different versions of your stored procedures and keep them, manage them separately in the cloud. They're hard to debug. DBOS stored procedures can be flagged to execute locally. We do not debug them on the server, right? So we're still not doing direct direct stored procedure debugging. But by easily flipping a switch, you can debug your stored procedure locally. Now, of course, in that kind of a scenario, you're not actually using the stored procedure, so you're losing the performance gain. But usually when you're debugging, you don't care as much about the performance. And DBOS's unique time travel debugging infrastructure automatically executes stored procedures locally during debugging. This makes using stored procedures in DBOS almost as easy as running your code on the application tier. Let's see what this looks like. So this is the TypeScript code from the create order function that we looked at earlier. I realize not everybody on this call is an expert in using DBOS, so I want to call out a couple of things about this code that are particular to the DBOS framework, the DBOS Transact framework. This code is decorated as a transaction. We have decorators for transactions, for communicators, and for workflows. And this is what allows DBOS to understand where they need to do interception to be able to insert that oops logic management that Andy mentioned earlier, the reliability code to automatically make these calls atomic and reliable. The first parameter for transaction functions is a transaction context. This provides access to a variety of different information that's available in the DBOS platform. What was the request that originally invoked this workflow? What is the security user and context? What is the workflow identity? How do I want to be able to log from inside of my method? I want to access the configuration engine. And for transactions, I need to be able to communicate with the database. You'll notice the transaction context is generic on Connects, because as I mentioned earlier, we support a variety of different query builders and object relational mapping systems inside of DBOS. So here we're using Connects. We have two separate calls, one for each of the different insert commands. And as I said earlier, Connects allows you to write your SQL command using TypeScript, and it gets automatically converted into SQL for you. So this is the transaction version of create order. The stored procedure version is a slightly different. So obviously right off the bat, we have a different decorator and a different parameter, and my animations are all kicking in too early. Sorry about that. We have a different decorator and a different context. The context is not generic because we do not support different object relational mapping systems inside of stored procedures. The PLV8 environment is a JavaScript environment, but it is not node compatible. So existing object relational mapping systems and query builders like Connects do not run inside of the database. So you do have to use raw SQL. And you can see here that we're doing that. We have the insert command for both the orders and the order items query. We're then automatically invoking we're invoking the query using the query function that hangs off the stored procedure context. This API is designed to work similarly to how the Node Postgres library that underpins all of the various object relational mapping systems that DBOS supports works. You'll also notice here that where in the transaction function, we submitted all of the order items in a single insert statement, here we're looping over the collection of products and inserting them one at a time. When you execute your business logic on the application tier, reducing the number of round trips is critically important for performance. But it also makes the SQL command more complicated. Since this code is actually just running on the server and we don't have that network round trip aspect, the difference in performance between doing this as a single insert versus doing this as a for loop of insert statements is minimal. It would be very slightly faster to do this in a single insert statement, but it would make generating the SQL statement more complicated because it would be a dynamically generated SQL statement, where here it's just a constant string. So let's talk a little bit about the DBOS compiler under the hood, and then I'm going to show you some code. So the DBOS compiler is a custom part of our project. Source code is up in the GitHub, in our GitHub repo, so it's all open source. Its primary job is to extract the store procedure methods. So it does this by eliminating all of the DBOS methods except for store procedures. Store procedures cannot call transactions, they cannot call communicators, and they cannot call workflow. So it removes all of those automatically. Then it tree shakes out any code that isn't used by stored procedures. The idea is to cut down all of the code in your application to just the stored procedures and the code that it depends on. We then remove all of the await codes. PLv8 does not have an event loop, so it cannot execute asynchronous code. The equivalent of the the equivalent of calling query in PLv8 is a synchronous call. And again, we don't need to make a network round trip, so making that synchronous is completely appropriate. It does mean that if you try to do await calls that are not calling into the database, there might be some issues there because of the fact that we do remove all of those await calls. We remove the decorators because those are specific to TypeScript and they do not execute in JavaScript. And then we compile whatever's remaining to JavaScript using the official TypeScript compiler API. Once we have all of our JavaScript code for our store procedures, we then generate functions and store procedures for Postgres. Now, we've been using the term store procedures all along here, but Postgres actually supports functions and store procedures, and there are subtle differences between them. In particular, store procedures allow you to manage transactions, and functions do not. And of course, because of the fact we have to do a bunch of transaction management as part of the making these calls atomic and reliable, we have to use stored procedures. We also generate functions for all of our JavaScript code. So every module, every file that has stored procedures or stored procedure dependencies becomes a PLv8 function that gets deployed to the server. Every stored procedure function has a PLv8 function and a PLPG-SQL stored procedure. It turns out that managing return values with PLPG-SQL is easier than doing it with PLv8. So we're actually using both, but from the perspective of your perspective, that's an implementation detail that you don't have to pay any attention to. And then finally, we automatically version prefix if there's a specific environment variable set that indicates the version of the code. So we will automatically prefix the code with the version stamp if it's available. So now let's take a look at some code rather than continue to go through PowerPoint slides. So this is the shop backend. As I mentioned, we're looking at the create order function. We haven't modified this entire application to use store procedures. We've only updated create order so far because that's the one that we talked about in this slide. This is available. This will be available up on GitHub. It's in a separate branch. We'll get this published after the webinar. So this is the original. I've renamed it create order transact. So you can see here is the connect code. Here's the stored procedure version. It's the same exact code as we saw, slightly formatted differently. Not a huge deal. Now you'll notice I have a breakpoint here. I'm going to run this code. I have a Postgres running with PLv8 already enabled, running in Docker locally on this machine. I'm going to run the migrate command to configure the database. So we're sitting here, we're running the migration step. So we're automatically using connects migrate. We're running a seed, and you'll notice that we're running DBOS deploy. And so we'll see here that, close this down, we've automatically configured the database to have both the schema changes and the stored procedures that we need to execute. If we look at the DBOS config file, again, I realize not everybody in the audience is going to be a deep expert on how DBOS works, but you can see here that we have a migrate file, and this is basically the list of steps that you execute. So just by putting npx dbos c deploy will automatically deploy your stored procedures to the database. When you take a look at the actual database code here, you can see that inside of our shop application, we have a DBOS schema. That's where we keep track of all of the transaction output, and we have some shared stored procedure functions, some Postgres functions that we use as part of our stored procedure code. And then we actually have generated the shop create order function and the shop create order procedure in the code. Now we could look at it here in this view, but I'm going to actually run npx DBOS-C compile. So when we deploy, we call DBOS-C deploy, and that automatically generates the stored procedures into the database. But if you call compile, it'll actually just generate it into a file. So we can actually see now that we've generated this new file, create and drop. So we can take a quick look at the create file where you see we're enabling PLV8, we're enabling the DBOS schema, and then we have a bunch of these helper functions. So as we mentioned, we have a bunch of existing code. All of these stored procedures work the same way as the reliability logic when you execute the code on the application tier. So this is code that checks to make sure, hey, have we actually run this step before, right? Here's the workflow ID, here's the function ID, check to see if it's been run before. We have some code for flushing. We have some optimizations for read-only queries. That's what this does. And then we have this helper function run with the $sign. This sets up all of that context. The stored procedure context is similar to the context for transactions. As you can see here, we get information about the request. That's the original HTTP request that came in that triggered the workflow identification, information about security, and then here's the query function. And we also have access to log information. So if you call into the logging infrastructure, we automatically use the underlying elog infrastructure that PLV8 exposes, send that back to the application tier. So any log calls you make in your database, in your stored procedure, get replicated back and are included in your application logs that you can access from your DBOS dashboard. So this is all common infrastructure code that we have. Every single stored procedure application will have this. And then this code from here down is your code. So you will see here, this application has a single module operations. There's only one stored procedure in it. So you can see here, this is the generated stored procedure. Order status is a dependency that the create order function uses. So that's been included. But all of the rest of this code here in this TypeScript, all of this stuff has been eliminated. Of course, all the type information is TypeScript only, so that gets eliminated by the TypeScript to JavaScript compilation. But all these other functions and all this other user code, like these constants and this helper function, none of that stuff is used by stored procedures, so it all gets tree shaken out and removed from the code. So we're only left with the create order function. So then if we look at the actual function, what this is going to do is it's going to be able to call the init function and the operations init function if this hasn't already been configured, and then it calls that run function. So the run helper function and the operations, the shop operations object. So this is just, the primary code. And again, this is all PLV8. You can notice here that we are specifying PLV8. This is where the actual logic is. This is just a simple wrapper to make it easy to invoke. And then we have the stored procedure. This will check execution. This will flush buffered results for read-only. We didn't really talk about that, but it's an important part of the optimization for read-only functions. We call the function. We check to see whether it returned an error. We didn't really look at error code on that initial slide, but of course, if you're going to record your outcome, you also have to record your outcome if that function throws an error. So we returned it as an error, and we insert that into the database. By the way, this code that gets generated is different based on whether or not the stored procedure, for example, what isolation level you're running, and whether or not it's a read-only or a read-write transaction. This is a read-write transaction. In a read-only transaction, this code would be slightly different. And then that's it. We also have a drop function, which of course just drops all those routines. Now, you'll notice here that if we look if I scroll back down to the stored procedure, I've put a checkpoint here. I put a breakpoint here. So I'm going to go over to the test code, and we're going to run the create order test in the debugger. And as you'll probably imagine, we're not going to actually, the test will succeed. I hope the test will succeed. Yep, the test succeeded, but we didn't actually hit the breakpoint because, of course, we're running this as a stored procedure. We're not actually running this code locally. So what I'm going to do is I'm going to go back to my code, and I'm going to flip that switch I told you existed. Execute locally, true. So now I'm going to, the tests for this project expect a clean database. So I'm going to npx dbos rollback, npx dbos migrate. So this is going to roll back and remigrate. It's basically going to clean out the database so that it'll be fresh for the next test run. But I also want to point out something. We're going to see slightly different output from dbos deploy when we do this. You'll notice here that it's giving me a warning. You're deploying this as a stored procedure, but you've configured it to run locally. So for production, this is probably not what you want to do. Of course, we're debugging, so this is exactly what we want to do. But we still flag this up as a warning for you to know that it's just to highlight to you that you've done this. So now I'm going to go back to my test code, and I'm going to hit the debugger. And you'll see that we've actually stopped in the code. So one of the great benefits of using PLV8 is it is a JavaScript library, so it runs basically the same regardless of whether you're running on the app tier or on the database tier. You'll notice I said basically the same. There are some small differences. We've noticed in particular the way that rounding works with floating point numbers is different. Node PG will automatically truncate to like 2 decimal places, where PLV8 will give you the exact floating point value, even if it's out to like 10 or 12 decimal places. But of course, this was some pricing information in a different demo application, and storing pricing information in a float is probably not a good idea. But now you can see that I can step through my code. I can see, I can, get the normal kind of debugging experience. And again, we're doing our insert as in a loop, which isn't great from a performance perspective, but we are debugging, so we don't really care so much. So now you've seen create order as a stored procedure. We've seen how it gets deployed. We've seen how it gets run, and we've seen how it gets debugged. So with that, DBOS stored procedures, the good, the bad, and the elegant. DBOS stored procedures, stored procedure performance, that's the good. We're seeing dramatic improvement, a 2x improvement for even very simple business logic because of the reliability and atomicity needs. Stored procedures, developer experience, that's bad. There's a lot of friction that comes from trying to build stored procedures without using DBOS. DBOS stored procedures give you all of that great performance with none of the developer experience friction. My name is Harry Pierson. I'm a staff engineer here at DBOS. I am primarily responsible for developer experience for DBOS. I own the time travel debugger proxy. I own the Visual Studio extension for time travel debugging, and I built the DBOS compiler for stored procedures. This is my email, and I'm available on most social medias as DevHog. So with that, thank you so much for attending. And do we have any questions, Andy?
Thank you, Harry. We do have questions.
Cool.
Let's get into them. First one is about the compiler.
Yes.
Somebody asks, is do we use the same version of TypeScript to compile the stored procedures as we do to compile the application code?
Yes, we do. We try to keep our TypeScript version up to date. We do have one of the things that we have in TypeScript in DBOS is an open API generator, so that way you can automatically generate an open API schema for your DBOS application. That makes it easy to build client applications. We tend to be gated on the update of the there's an existing library that we depend on for that. So when a new version of TypeScript comes out, we have to wait for the new version of the TypeScript to JSON schema library to come out. But we try to keep up to date. We're usually only like one minor version behind it at most.
Okay. Thank you, Harry. Next question. How do rollbacks and error handling work? Can you use try and catch in stored procedure functions?
Yes, you can. So if you, I'm going to switch back here to source code for a second. If we look at the actual generated SQL code, you'll see that we have the, this is the operation. So this is the generated JavaScript. And in this case, you'll notice the create order does not have a try and catch in any way, shape, or form. But then the run function that we're calling, we have this locked inside of a try catch function. So we return the information as either output or error. So we automatically convert the thrown exception into an error object. So if you're familiar at all with functional programming, if you're familiar with the sort of the result type, this is essentially what we're doing. So we're returning a JSON object that has information about either the successful execution in the output or the error execution in the error field. And then if we scroll back down to the Postgres function, you'll see that we actually look for that. So we get the call back, we call the function into return value. We have to do some other bookkeeping for snapshot and transaction ID. And then we get the output and the error functions into these variables. And then we check, hey, did this throw? Is this an error? Right? And we have to check, because of the way JSON works, it could be the value null, or it could be the string null, right? The JSON string null. If it's an error, we roll back the original transaction. We have to flush the buffered results again. And then we insert into the transaction output. That's where we record durably the output of the transaction function. We record that error information. And if it's a success, then we record the output into that same transaction output table. If we look in the database real quick, you can see here that we have this transaction output table. So this will basically say workflow, this with this name, we generate GUIDs by default, but you can make this any string you want. This function number had this output. So this had a 1 as the output. This had a 1 as an output. This had a null, which would be a void function. These all have null error. And then there's other information that we record, which we use for time travel debugging. This was the transaction, this was the snapshot, and this is when it was created. So this is the same exact behavior you get if you use an @transaction function. We basically ported all of that reliability logic from TypeScript to PostgreSQL so that we can run it as a stored procedure.
Great. Next question is, which databases are supported by this?
Postgres.
Thank you. Quick answer.
Michael Stonebreaker is our founder, so go figure. Postgres is the database of choice for DBOS.
Yep. Next question. So are methods that are decorated with the @transaction in your code, are those also version controlled? If not, what happens if you introduce a breaking change in the logic?
Well, transaction functions run on the application tier. So they get versioned along with the rest of your application. And so because application servers tend to be stateless. So part of the methodology, the mentality behind DBOS is you store all of your state in the database. Full stop, end of story, no exception. So the application servers are purely stateless. So you can run different versions of them, right? So when you deploy to DBOS Cloud, you'll deploy a version, it gets timestamped. That's what we use for version. And then you'll have you'll execute some operations, you'll execute some workflows. Maybe they're still in process and you deploy a new version. We don't sunset the old version until all of the associated workflows have completed. So we'll run both versions of your application until all of the old workflows have completed. Then we decommission it and we leave your current version, and any new requests that come in get directed to the new code. And your transaction code is just versioned alongside the rest of your workflow and communicator code. You do have to worry about, like, if you make a change to your database, since you're running both your old version and your new version, if you add a new table or something like that, or add a new column to a table. But this is fairly standard. Every application has to deal with that. Every database application.
Cool. All right, we're running short on time. I think maybe one more question.
Sure.
Will this be made available for Python? Of course.
There is, unfortunately, unless Jerry is working on a Python one, and I assume he's not, there is a Python language implementation for Postgres, but it is untrusted, unlike PLv8. And so it is not supported by any of the cloud vendors. So we are working on that, but have nothing to announce about that right now, other than it's not going to be able to work the same way as JavaScript or TypeScript stored procedures because of the lack of a existing trusted language implementation for Postgres. But we absolutely, this is a huge feature for DBOS, and we absolutely want to bring it to Postgres as well, to Python as well.
Cool. All right. Thank you, Harry. At this point, we're going to wrap up. Sorry we couldn't get to all the questions. We'll answer, we'll get to the rest of them via a follow-up email. Look forward to seeing you online in a future webinar. Thanks very much for attending today. Bye, everybody.
Thank you.